Alright, so this will be the lathe introduction for Module 1. So we're in Blackboard like we started before, and we'll go into Structural Modules, Mod 1, and then make sure you watch the mill video first because it gets into some of the details as far as making sure you get the handouts, print them, put it in a binder, download the CNC edit software, and we were in the mill assignments folder. So this time around we're going to be in the lathe assignment. And there's only one lathe part to make. In here is the support content. There's a lathe operator handout, which we'll go over quickly, the lathe programming workbook, and a G71 handout for helping you diagnose one of the first CAN cycles you're going to be doing. Other than that, there is the lathe part. Now, just to note here, we are only going to worry about facing and then turning, roughing out this workpiece on the outside diameter for this example. The inside work will be done in a later module, so the outside only for now. Okay? So get back in here and let's take a look at some of the support content, and let's start with the lathe operator handout. Very similar to the mill, except for obviously it's for the lathe. It gets into the index here, then types of lathes, ST series, TL series, DS series for dual spindle, chucker lathes, etc. Types of turrets. We have a VDI turret here on our turning center. The other type, we have this type, the 8-station automatic turret. This is only on our CL or chucker lathe. And other than that, we just have the regular dovetail Allura style tool posts that you are used to from the manual shop. So we will cover the VDI turret at a later time when we're going to be running that machine, because it's a little different. It has an automatic tool presetter, things like that. So a lot of this stuff we're not going to worry about right now. It goes over the pendant. It is very similar to the mill, but it has different buttons that are applicable to the lathe. At least on the machines we're going to run first, there's only 2 axes. It gets into all the locations are about the same. The tool offsets are a little different. How you set tools a little different. We'll talk about that. Overrides are pretty much the same. Jogs a little different. Same layout, different values. All right. Mode keys are pretty much the same. Loading a program is going to be the same. Not a whole lot of differences here that I'm really seeing. It's just more applicable to lathe. What you're going to want to see when running a lathe. Okay. Make sure you keep this. Make sure you print it. Very important at the machine. It'll get you out of a bind if you're stuck and don't know where something is, in case I'm not available. Position, again, is going to be X and Z. Could have a C axis. Could have a Y axis, depending on what the machine you're on. All right. How do you navigate them is going to be the same. Display keys are going to be the same. Again, it's going to be a little bit different tool table because it's lathe. Your tool lathes, tool nose radius, tool position. It does have probe type for probing the tools automatically. X and Z geometry and wear, radius wear, tip direction, things like that. It'll be a little different. Okay. Current commands is similar, but that's really about it that I see. Again, you're going to see some right underneath the F1 buttons. You'll see some differences. Those are for setting up tools. We'll talk about that in the shop. Okay, the help menu is pretty much the same. Again, instead on the mill, you're going to see tool length offset and work offset. This is Z face measure and X diameter measure, a little different. Types of tooling it gets into: stick tooling, parting, internal work, face turning. Again, these are specific. We're going to use more of the regular stick tooling for now. And then programming, some of the basics. This goes into a little different changes versus the mill manual. Absolutes versus incremental programming, which I'm not going to revisit too much. Then it gets into the VPS, which we are not going to use right now. The VPS for probing is useful when we get to that machine. That's one machine in the shop that has that. We will cover it. But the shape creator and other onboard programming, the VPS, we are not going to cover till later on. The reason for that is that this is going to be HAAS specific. And what's going to happen is if there's not a HAAS machine where you go to work, then any skills on this is going to be, it's going to be a problem. So I'm going to try to teach you ways that are a little more universal so that you are ready to run almost any machine tool for the most part. We'll get into VPS at a later time after we cover a lot of the more universal basics. Machine maintenance, 15 easy steps for preventative maintenance, very important. Then resources, you can click on this in the link. Okay? So that's the overview of this lathe operator handout. The lathe programming workbook we'll have open, and what we'll do is we'll go to the whiteboard and we'll talk about some of the basics in programming, some of the basics on the lathe, touching off tools, things like that. And you'll see there is a difference in the program format. You'll see that sometimes there's less code in a way. There's less things that you have to worry about in a way. I find that lathe programming does throw people for a loop because a lot of lathes run on diameter for all their X offsets. And even when you're setting tools off, you see numbers that don't make sense because you're working on diameter in the X. So let's take a break here. Go ahead and take a quick look at the workbook, and then I'll come back on the whiteboard and we can sort of discuss some of the basics here on a whiteboard. Alright, so we're on page 5 in the workbook, and I'm just taking a look at the setup that they have here. You'll see the chuck, the part, and the axes. So essentially, all HAAS lathes, whether or not they are, the tool comes from this side, bear with me a moment, comes from this side or this side, you always program it like it's coming from this quadrant to turn a diameter, okay? So that's the way we're going to program. Some important things here. The lathe, if this is our chuck, okay, and this is our workpiece, all right, the work offsets work a little bit differently. On the X is this direction, the Z is this direction. The work offset, usually you do not need anything in the X because the X is center, 0 is center of the spindle. Okay, so X is 0. In work offset, let's say G54. Okay, the Z in the G54, all right, normally when using work offsets would be here to a preset location, let's say the chuck face. Okay, because using the lathe, if you're not using a presetter, or not presetter, but a tool touch-off probe, a lot of times most people will touch off all of the Z's to here from home. Okay, and then all of the diameters will touch off a known diameter, all right, and compensate from that diameter to the center, or X0, the center of the spindle. So some people will touch off the part, take a little cut, measure the diameter, use what's called X diameter measure, and then you'll end up typing in whatever diameter that is, and that'll automatically calculate the distance, not necessarily the distance, but the swing that, or the diameter that the tool will cut when home. So if the machine is home and the tool is actually sticking out, let's say, the tool looks like this. All right, something like that. Looks like a hockey stick, but whatever. This diameter, when the machine is home, that this cuts right now, okay, is what's going to be stored in the controller for the X offset. Okay, so you'll see numbers that are 13 inches, 10 inches, whatever it might be. That is because it's checking, it's a diameter right here. All right. So that matters for all OD turning tools. Now for ID turning tools, it'd be a little different. You would have to have a hole existing and touch off the ID and do X diameter measure to the ID. We'll cover that in a later video. Now, some people do touch off the outside of the chuck, okay, and then measure the chuck or have a known measurement of the chuck, and then type that into the X diameter measure, and that way you're not touching off a workpiece. Either way works. I do find that when learning, it is easier to touch off on the workpiece, take a little cut on a piece of scrap material, measure the diameter, and go from there. I think it's more accurate for what you're doing when learning, because sometimes with the chuck, if you're using shim stock, that really needs to be taken into account, because even if it's a 3/1000 shim stock, everything's on diameter, so it's twice the error, so you can run into issues. Okay? So it's very important to do that. Now, like option 1 on the milling machine, you can touch off all the tools. Let me erase some of this a minute. You can touch off all of the tools to the face of the workpiece. Okay? So if this is our workpiece, all of the tools could go from here. All right? Here's again the problem with this. If the workpiece length changes, you have to touch off all the Z's again, or know that distance. If you touch all the Z's off of the chuck, and then with a taut tool, come off and set your G54 to the face of part, that way your tools are taut the entire time. But it's up to you. The tools will most likely be re-zeroed when you enter the lab. If you're using one workpiece, you're not going to be running others. Then it probably doesn't make a difference. You are going to be fine to use the option 1 equivalent on the lathe, which would be to just touch off the tools to the part. Okay? And sometimes if you're doing multiple workpieces, that way you'll set up a stop from here to here so you can bring the stock out of the chuck to the same spot every time to run another part. So that's up to you. So again, just to reiterate, you could have no G54 offsets and touch off every single tool to the workpiece on X equals diameter and the Z face. Okay? That would be equivalent to option 1 on the milling machine. You change the length of the part, you got to touch off all the tools again. If you do it the other way, and this is a good way if you are, it's your machine, you're not really messing, you know it's going to be good. Nobody else is messing with it. If you touch off the tools, especially in the Z, really only the Z, if you touch off all the tools to this face, so this distance, alright, this would be a tool offset. Okay? Then have a G54 offset using this taut tool from here to here. Now the tools are taut, and then all you have to do is change one offset to change, let's say, 10 tools. So it's much faster that way. It's very similar to using the 1, 2, 3 block on the milling machine. Okay? So just remember that. So let's look at a couple other things when it comes to this. Let's go through the book here. We're getting incremental and absolute, very similar. It goes into, on page 8, it gets into a very important thing. If you look on page 8, it gets into, let me clear this. In page 8, it gets into point locations. So the Z is not a big deal. Okay, we're looking at, actually it's 7 and 8. You'll see the part on page 7 and then a little chart on page 8. And then there's also information on page 9 that gets into corner radius, locations, and that's really good too, but we'll focus on that later. Take a look on page 7. You'll see the workpiece, and you'll see that gives out diameters of 1.5, 2.0, and then some Z distances. Take notice that, actually, let me pan over to this. Let's look at this. So I'll bring this over here, and take a look on this example. 0.1, 0.2, 0.3, 0.4, 0.5. Okay, diameter, not radius. So one thing to take into account here is that on a chamfer, let's say, this chamfer, the diameter created at 0.1 is what you need to enter in for 0.1. So let's go up on the top here. This chamfer is 1/4 inch by 45 degrees. So it's not going to be 1.5 minus 1/4 inch. It's got to be 1/4 inch times 2. It's 45 degrees. Each side of that triangle is the same. So it's going to be 1 inch. Okay? So when you get down into this chart, 0.1 is 1 inch on the X. The Z is 0. 0.2, the X is 1.5. The Z would be negative 1/4 inch. Okay? Now you got to go down to here. If you get to 0.3, the X is going to be the same, 1.5. The Z is going to be minus 3 inches. Okay? When you get to the radius, okay, 0.4 is when it gets tricky, because now you have a similar situation we had with the chamfer. You got to subtract 0.2 from 2 inches, okay, or 1.8, okay? And what's really important about that is that's going to be the diameter before the radius. So for 0.4, it's going to be 1.8 and then minus 3.0. Then we go up on the next point, which is 0.5, and that's going to be x 2.0 z minus 3.1. Okay, so work through that, take a look at it. All right, just remember that all the x moves are on diameter, every single one. Okay, we get to the next example. You can work through this if you want now. It doesn't really make a big difference. We did go over a small radius here, but I recommend you work with that. When we get into circular interpolation, we'll get into more details on this. Okay, so that's fine. And again, it goes through in parentheses. You don't need it again. We went through that with some of these, going from 0.2 to 0.3. 0.2 to 0.3, you don't need another x value because it's already there. It's not going to change. Okay. Then we get into programming with codes. The program format does change, but let's pause here. I recommend you work through these. If you're having an issue, make sure you email me or see me in lab. And then we'll pause here, let you catch up, and we'll continue. All right, so we're going to continue taking a look at some other program structure things when it comes to lathe, some of the differences. So I'm on page 27 in the workbook, so let's skip ahead here and get right into this. And again, my concept here is I kind of do this so that we practice what we need in process without having to, really go through the workbook. We will cite it as needed, and I find that really helps, especially back up what you're doing in the lab. So just like milling, we do need to start and end our CNC programs with a % sign. And you still have the O number, so O and then 20, 21, or whatever you want. Let me clean that up a little bit. All right, and then we get into our first line of code, and you're going to see a lathe, especially from the examples you'll see in the text, a little more broken up. Okay, we will really have our first exercise with mandatory line numbers for this example when we start using our rough turning subroutine. So let's cover that now. I don't remember if that was in the milling, but on some programs you will see an N, like let's say 5 and 10 and 20, whatever. Those are just line numbers. They are great for editing, but you do not need them necessarily. Okay, so a lot of these simple programs that we're going to be working on, especially on the mill, until we get into subprograms, you don't need them. They are handy. You do need them when turning a little bit. You'll see I use them only as needed because there's extra things you have to type in. For any advanced programs, like when you're using Mastercam, it automatically kicks it out. You can automatically add them in Discriminator, so it's not worth typing in. And my programming method, I don't use them unless I need them. End of story. Some people do it differently. It's up to you. So if you do see the line numbers, N, whatever it is, sometimes it's not N 1, 2, 3, 4, 5. It's going to be N 5, 10, 15. So you can add lines in there easily. Not instead of putting like N 1.1, it'd be N. Instead, if you need to add it after N line 5 or N5, you can add N6, N7, N8 easily at the controller. So for right now, we're going to skip that, but I just wanted to mention what the line numbers are. We're going to end up calling up tool 1, and it's going to be T1, O1, okay? So the key here with T1, O1 is on the lathe, you need both axes when turning anyway, so you need the X and the Z offset. So you just have call up tool 1 using offset 1. And this gets interesting because sometimes you could put tool 1 offset 3, offset 4. And this offset takes care of Z and X equally. All right? So that's different. It's no T1M6, it's just T101. Now, your next line is going to be something to do with spindle speed. Let's get the spindle turning when the turret's away or when the tool's away, and get it turning, get the part turning. So the first line, and this order is specific, you really need to have this G50 on first, and we're going to call S, let's say 1000. And that limits the spindle, or spindle max speed, at 1000 RPM. Because on the lathe, we're going to have what's called constant surface speed. So we're going to turn it into, so when turning, especially when facing, you're going to get the same feed rate the whole time, or the same chip load. So as the part gets smaller, the surface speed will automatically be calculated by the X location, and it'll spool up the RPM to keep the surface footage the same. Okay? So you need this limiter. Okay? And again, we are on page 27 in the text. You see, if you're following along the text, I did skip the N1 and the G28. I'm not really worried about that for right now. Next, we're going to have just turn the spindle on. Okay, like I said. And G97 turns the spindle on a fixed RPM. Okay? G96 turns it on to a constant surface speed, and the interesting thing here is that the S value turns into that constant surface speed, not the RPM. So right now we'll end up putting a G97. Let's say it's S100. Just turn on 100 RPM, get it turning. Okay, and M3. And M3 is going to be, if you're looking at the chuck, it's going to be counterclockwise. It's going to be turning the way to cut correctly. Usually a lot of these, at least in my experience, the surface, you got to be looking at the back of the machine or from the other side of the chuck, and that would be clockwise, and that's how they derive it. But depending on what your machine you're on, especially even in live tooling situations, you got to make sure that that thing's spinning the right way before you turn it on, and that can vary by machine, so make sure you double check that. All right. The next line of code, we're going to have a work offset call out, a rapid line, go to a start position, and then turn the coolant on. Okay? That's right out of the, I'm just trying to follow along with the text here to keep some sort of continuity. Do you have to do that? No. You could break this up. Do you need the G97 right now? No. You don't necessarily need it. Okay? But it is wise to get the spindle turning. Okay? You just don't want the thing to spool up to some RPM. Okay? This G54 line here, so it's going to be G54, and you could put that separate if you want to for easy editing. You know, G00, and then you could go to the next line, X, whatever, Z, whatever, and then you could turn coolant on separately if you like, just so it's easier to edit. Okay? So the G54 is taken care of, and the offset and what tools in there is taken care of. The spindle is on. All right. And then it gets into the constant surface speed, and coincidentally, it does turn on a G71 command, and we'll talk about that in a minute, what that does. But I think that doing that in discriminator will help. So let's get into discriminator. Let's start getting this code going for our example workpiece, and we'll continue from there. So we'll take a break right now. Okay, so we're in discriminator. Let's get over into back to Blackboard quickly. I will give you a page reference right now. We do have to set up the program to face the workpiece and things first, but we will continue on page 78 shortly. So get to that page while we're there. I'll get back into here and take a look at our workpiece. All right, so we're going to be working with 2-inch stock for this example. This stock, the workpiece max diameter is 1.5, so we do have some substantial roughing, a little bit of roughing to do. So let's start programming this workpiece. So we'll get over into here, and let's start with a % sign. And let's get in here. Let's just go T101 and call up tool 1. So we're going to parentheses over here, and tool 1 offset 1, and we can add a comment right below here if we want. Our O number is obviously needed, O, 20, 21, or whatever you like. And then comments are also fine. Lathe example. All right. So got tool 1, offset 1. That's loaded. A couple things you could put here. Even before turning the spindle on, you could add what's called G99, which just forces lathe to inches per rev, which is handy. That's in the text. So take a look at that. That's fine. There's some codes, G18 forces the XZ plane. They default to that, so I wouldn't really worry about it for right now. So we can put G99 in just to be safe. We could do G40, G80. Those are things you could cancel, but a lot of modern machines, they cancel them automatically, or you already did. So I wouldn't really worry about it for right now. We'll try to get these programs as tight as possible so that they're easier to edit. So let's get our spindle turning. Okay, so that's going to be at G97. Let's just do S. Let's say it's at 200 RPM. And that's fine for now. But again, before that, you must, before this, put your limiter, G50, S, and we're going to limit it to 1,000 just to be safe. So in parentheses over here, let's get in here and put IPR. And right below it, for our limiter, RPM limited to 1000. And then we have our straight up RPM call out. So it's going to be turn spindle on to 200 RPM. And we are missing one code here, which is going to be our M3. So now our spindle's running. Okay, and now it's wise to start getting some movement going. We don't want to turn constant surface speed on with our G96 until we're close to the workpiece diameter. And where we put this is going to be critical. So I'm going to put my G54. All right, I'm going to keep it separate. All right, I'm going to end up putting my M8 here. You don't have to. It's probably not. You know, it depends on if there's a delay to your coolant. So if there is, you want to put it on a little bit earlier as the machine's moving. But for us, it should be pretty instantaneous. We could even put a dwell there or something. It's not a big deal. But I've ran into some machines where sometimes a check valve is damaged and it takes a while for the coolant to turn on. So just something to be wary of. Okay, so we got a work offset. We'll put G54 and G00 just to be safe. And then we'll go to X, and we're going to go to X 2.0. Z.1. And our stock is 2 inches in diameter, and we want to be 100th thou away on the face. Not a bad way to go. The other option you have is it is not critical at this point. We can go to a X 2.1 and then separately go to a Z.1. And the point here is it'll move in the X, then go in the Z. You could do the Z first, then the X. Whatever you need to do to make sure you don't crash into the workpiece. Okay? So it's up to you how you want to do that. You got to watch out for your centers, tail stocks, and things. It's up to you. Either way will work. So now we are at a diameter of 2.1 and 100th thou away from the face. We now need to get closer to the face, or we need to go to Z 0 point. So we're going to face this to 0. So we're actually going to cut to 0. Now, if you touched off the workpiece in Z and you cut it, you're just going to recut what you already cut. So you don't necessarily need to face it, but you need to take into account that if you're doing more than one part, that you set the stock out further than your offset, so it'll cut material, or that right now, you would just change the offset. You could change your Z offset in G54 or your tool offset in the Z by whatever value to get it to cut, 30 thou, whatever you want. So we will go to Z0, and we'll wrap it there. Okay? The next option we have is we need to take our first cuts. So let's get our spindle running at a surface speed. So we'll go G96, and let's say S200. Now that is slow for carbide, but it's okay for now because we're going to cap it at 1000 RPM anyway. So as this part faces, okay, it's going to face, and the spindle is going to stay at 200 surface footage no matter where the X is. So as the part faces down, it's going to spool up and keep that surface footage the same. Okay? Really nice, keeps the same chip load on the cutter. So we'll put this in parentheses here. Constant surface speed at 200 SF, surface footage, SFM. Okay? Now we're ready to face this. Okay, so we're at X 2.1, we're at clearance, so we will go to a G1 line now, our linear cutting. So G00 is going to default to the rapids, the percentage of full machine rapid movement in the lower left-hand side of the controller, or the fourth set of buttons down in the overrides to the right of the feed hold button. You'll have 5%, 25%, 50%, and 100% rapid. Is this, that is what G00 is going to work with. G01 is going to be a specific feed rate to cut. Okay, and that's the same for lathe and mill. The difference is that the lathe is going to be in IPR, inches per rev, and the mill is going to be defaulted to inches per minute. So we're going to go to X minus 0.01. We want to face beyond the center of the workpiece. Okay, so past X0, so minus 10 thou. And we're going to go to feed rate of, let's say, 5 thousandths per rev. And that'll work fine for now. So we'll have linear feed to X minus 0.01 at 0.005 IPR. Okay, it's good for now. And that's a slow feed rate. It's good for practice. We are not running optimally at all. For your first assignment, I am going to cap your RPM at 1,000. I won't want any hazards here. They will spool up. Our turning center will go around 6,000. I think the tool room lathes go around 2,500 or 3,000 RPM, something like that. So I want to keep the RPMs low just as your first, your first trial run here. So we just faced the workpiece. Okay, we went down and cut. So what we need to do now is get the cutter away. All right, so I'm still feeding. I'll leave the constant surface speed on. I will end up going to X or Z.1. Okay. Get away from it, and then I'm going to go to G97. Okay. I want to turn the constant surface speed off because I don't want it to spool down coming out. It's not a big deal. I'm just going to go to S 200. Just turn it 200 RPM. Okay. It's not a big deal. We really don't necessarily have to. Okay, but it's up to you. The machine will wrap it right down. It's up to you. You could even go to S, 1,000. It'll cap out, or S 500. It does not necessarily matter. If you do leave G96 on, as the X moves, the machine RPM change. So that's totally up to you. Just something I wanted to bring up. Okay, so we'll right now just go to G00. And I'm going to go to X 2.1. All right, so we just faced the workpiece. All right, now we have to get into actually turning the workpiece. So right now, we're going to end up using our G71. And what G71 does, and unfortunately Discriminator does not show this, just Discriminator is only going to show you the profile you're cutting. G71 will automatically rough out a profile given a depth of cut, stock to leave, an X and Z, and a feed rate. Automatically rough it out a diameter, whether it's ID or OD. And there's two types of ways to do this. There's a G71, which is monotonic, which is one way, no Z moves. I don't want to say no Z moves, but it won't change direction. And it's not really good for profiles. Let's take a look here and cite this properly. If we get back into our support content, into our lathe programming handbook, and I'll go down and look for this. G71 is a very useful toolpath, or it's a subroutine. So we'll get down here. I know the manual goes over tool nose radius compensation first, but our example does not lend itself to tool nose, cutter comp on the lathe. We'll cover that when we cover cutter comp on the mill, which will be the next module, and that's important to cover them at the same time, I think. We are not cutting any chamfers on this workpiece, so it is okay to just ignore it for now. We'll get back into here, and again, I'm scanning. We start turning page 77, and it goes through the different cycles. We will be using G71 and G70. So on page 78, in case I did not already say that, we get into the parameters for G71, and then it gets into whether it's type 1 or type 2. Type 1, okay, cuts just like this. Cut, come back, cut, come back, cut, come back. Type 2, which is, I don't use that a lot. Type 2 gets into here on page 88. We'll go out how the machine knows the difference. And then you'll see that you can rough out different contours like this. Okay? G71 would not do this well. Okay? It's meant to just cut in and sort of like a simple roughing cycle. It's perfect for the part we're working on. It gets into width, tool nose radius comp. You do need that on some of these examples. But for right now, let's keep it real simple. I won't even cover type 2. I want to focus on type 1, how to call up type 1, and how to use type 1. Okay. So we'll go back up to the top here, and I guarantee I really want you to read this. You'll understand it. Let's focus on type 1. So you're seeing this our example. We did face the workpiece. It has some examples here. Face the workpiece. It does face it. They go down 60 thousandths. That's fine. I don't like to go down too far because it ends up rubbing the workpiece. You get yourself out of the way. They do it in one line. I don't like to do that because you have an issue. Then I don't like vectoring, which means moving two axes at once. If I can avoid it, I will sometimes. But I find that you can crash easier that way. But once you get comfortable, it is up to you. You'll see after that line, this line is critical with the G71 because this dictates where your stock is. After the G71, it is just the profile of the cut of what the part you want to have. So we are essentially at line 9. Okay, so we get back into discriminator. This right here, these two, are very important. We want to go to X 2.0 because that's our stock outside diameter. This sets where roughing begins. Okay? After this, we will start our G71. And I'm not going to put any values in yet. All right? I'm going to start below the G71. All right? And I'm going to put N10. All right, and what N10 is going to be the first line of our cutting. Okay? So between P and Q, so in the G71 cell, you'll see a P value and a Q value. And that is the beginning and ending of the contour you want to cut or rough out. So N10 in our case is going to be P10. Okay? So I want to go over and open up, and I'll go back here. I want you to see this. Go to your G71 handout and the support content handouts and take a look at this quick reference sheet, which is very handy. It goes through a couple instances here, and you'll see on their line you have G71, P2 to Q3. They have N2 to N3. So first and start. Okay, we'll get into the other values in a minute. Okay, but take notice here about what it says on your first line. Okay, it says G01 on the first block with the PQ shape. All right, because if you use G00 between the P and Q, it will cause rapid motion during the finish pass. So this is going to rough out a shape, take a finish pass, leaving how much you specify in the I and K. Okay, and then you can go back with G70 and actually finish it. So I just wanted to reference this. Make sure you check it out here. This is the G71 handout, the quick reference handout from HAAS. Okay, so back over here, we'll put a G1, and let's get into here again, and let's look at our drawing. So we'll get back into the lathe module and go to the HO26P1 part. And on our initial G71 line, right now, we are currently at Z.1 and X 2.0. This line needs to go to X 0.845, if my memory serves me right, and that's going to be this diameter here. Okay? Once you go there, the next line is going to go to a Z minus 1.0. Let's go back into here, and we'll go Z minus 1.0. We're going to have an X value of X 1.22. So in here, we'll go X 1.22. Then we'll go Z minus 2 inches. Then we'll go to a X 1.5, and we'll double check that number, X 1.5 here, the bigger diameter. And that's going back 3 inches, but we need to go past that. That's very important. So X 1.5 is fine. Then we know Z minus 3.25 is good. That'll give us room for our parting tool to come in later. Okay, so we're not cutting unnecessary material. Okay? Now, after we get to the Z 3.25, it is wise to bring the X to 2.0. Okay? It tells us the end of the contour because we don't want it to be necessarily ragged. And then we can put our N20 X. All right? And you got an option here. We're not using comp. Okay? So if we get back into here and just look at this example, and I'm just going to this one because it's a real quick way to get to it. This G71 handout I find helpful. You'll see that they end up, there is no comp on this, they end up going to the X 3.1, which is where it starts. That's fine, but you have to be careful when you have comp on. Some of the values change, some of the things change. So just take that into account. Don't worry about it for now, okay? But just know that we might mess with that later, okay? So get back into here, and the X 2.0 we will cut and paste on the N20 line. Okay. Now Q is going to be Q20. All right. And now we're ready to, send the tool home, things like that. But for right now, before we finish this G71 line, I want to pause, catch up with the profile of the workpiece, and we'll come back here and we'll take a look at what some of these values are, and then finish up the end of this roughing cycle. So, all right, so on page 78 in the workbook, gives you the parameters, whether they're necessary or not, in the G71. We have the P and Q, the starting ending block requirements, and we will need a feed rate. Beyond that, we're going to add a depth of cut for each pass, okay? Then we're also going to add a U and W, so finish stock remaining, okay? And with direction, we'll talk about that when we go to boring. We're going to be positive for this. It's a diameter value, okay? And then we're going to do a W, finish stock remaining with direction, and x-axis value. So let's get back into our program here. We got to add a U value. Now the U is how much you're leaving on the X on diameter. So if you want to leave 5 thou aside, you got to go 10 thou. Okay, get rid of the space here. In the Z, we'll go W, let's leave 5 thou there, 0.05. That way it's 5 thou overall. 5 thou on the walls, 5 thou aside, because again, U is on diameter, right there. Okay, x-axis diameter value, so important. Okay, we're also going to do a depth of cut. So we'll do a depth of cut of 50 thousandths. Small, but it'll be fine for our example. Then we'll do a feed rate. So we're not going to worry about necessarily calculating it right now. When you get to the machine, you're going to be limited on the RPM. I'm going to cap you at 1,000. So you got to take that into account when you go to roughing. Okay, so we're not running optimal at all. I know I said that before, but just realize that when we go to feed 8 thou per rev, that's fine. It's not very aggressive, but when learning, this will be your first time on a CNC lathe, this is perfect. So this should be good. Okay, we have our N20. And then after this, we have some options. We are going to go and finish this using G70, but we're just going to use a different tool to practice tool changes. So right now, we just finished our cycle. Okay, and I'm going to get the tool out of the way. So I'm going to go to X, let's say 3.0, and Z 1.0. Get the tool out of the way, and I'll make sure I'm rapiding on this move. The other thing is right now is that the spindle is still going to have a constant surface speed on, so it's going to spool with that, and that's okay. I guess there could be a time disadvantage there, but right now, I get, in theory, you could turn off the spindle. That's up to you. That's totally up to you. You could just turn it to a G97 S500, just let it coast at 500 RPM. Get the spindle away. That way it's not going to slow down, or this turns off the G96. And you'll see when you do that, whether you add that or not, you'll see what happens. It's sort of irrelevant, but just so you know, if you wanted to say eliminate the variable, that's at 500 RPM. The only thing that should be moving is the X and Z. No spindle speed change. This is correct. You could just turn the spindle off. Up to you. So after we wrap it out of the way, okay, I'm going to turn the spindle off. All right. I'm going to turn the coolant off, and you can change the order of that too. All right. I am then, now that we got that done, okay, I'm going to clear the offsets. So I am at T100. So it's T1, no offset. You got to look at 2 separate spots. So clear the offset. Not a bad idea. Okay. Now we can set it for a tool change. You could send it home. It's not a bad idea. G53, X, Z0 point, or X 0 point, Z 0 point. No vector back. Then we can go to T202. All right. So now we just change tools. So now we can copy and paste a little bit. What I recommend we do is copy and paste, not the facing, but let's just get this area out of the way. So we'll copy this, which is just, pre-staging our tool, and paste here. And now we have our G99, our surface footage information, which would change for finishing, so just keep that in mind. And I'm going to change the X to X 2.0, because all that material is gone now. Okay? Next thing I'm going to do is, now you could do a fixed feed rate, all right, but it is wise to use constant surface speed. So we already have our G50. After this X 2.0, okay, we could turn our G96 S200 on, okay, and that's fine. Now, as far as coolant is concerned, if I remember in here, we did not have a coolant turn on. I talked about it. That's up to you. Okay, I don't see the M8 anywhere in here. get into here, and you could turn it on before here. You could turn it on right after the spindle's on. You could probably turn it on right in this first move. So right after the X 2.1, you can go M8, turn the coolant on. That's up to you. Again, I talked about earlier. Talks about the delay and the coolant. It's up to you. Depends on what machine you're on. Everything looks good there. M9, I turned it off. In here again, going to the X2 move, I'll just turn the coolant on. And now we could take care of the Z movement as well. So we'll just go to Z.1, just to keep some continuity from before. Got our constant surface speed on now, so that's going to be running at a surface speed at X 2.0. And then we can take care of our finishing. So G70 is the finishing cycle. And all it's going to look for is a P value of the contour from before, so P10 and Q20. Okay, so all this is repeating this contour. Now, what about the feed rate? So what we need to do is type in a feed rate, feed 0.003, let's say, right here, on the first line, because this will be read during a G70, but overridden during a G71. Okay, so we got that there. So we got T202, IPR, limit the RPM to 1,000, turn the spin on 200, call up your work offset, rapid, turn the coolant on, bring it over to a position, X 2.0, Z.1, and again, you could break that up and move the coolant depending on if you're worried about hitting anything. That's fine. And after the G70, we have finished the workpiece. So it's not a bad idea to get up into here and use the same commands as we did after the G71 is done. So we can right-click, copy, right-click, paste, all right, and we'll do T200 for clearing. Spindle's off, we're good, and we can end the program with an M30. Okay, just for a reference, I want to get in here and get into the G70 information just for a text reference, in case you're wondering. G70 starts on page 82, and it gets into here on what it's all about. The example is right here. It looks the example, and you'll notice we did something very similar. They are using cutter comps, so take that into account. Just be wary. We're not doing that quite yet. Our example does not have any radii or angles when you need tool nose compensation, radius compensation. Okay? So that is really it when it comes to this program of our workpiece. So let's backplot this, or let's look at it in Verify, or plot with full viewer. Hit click here, and you'll see we have a profile. And now mine defaulted to lathe. I'm just curious what yours will do, but just click lathe here, and we should be good. Everything, you know, on the X, the readouts on the bottom here are going to read in XY coordinates, not on diameter. So, you know, take that into account. But everything looks pretty good. I don't see any issues right now, at least. So let's take a look at this on the HAAS machine. So backplot's good for getting the bulk of your contour, the results done there. But we have to use a simulator for this. Okay? So what I'm going to do now is I'm going to save this program, which I already covered on milling. I'm going to save it and load it in the simulator, and I'll come back in a minute, and we'll have the simulator open, and I'll load the program, and we'll take a look at it on the actual machine. All right, so here's our program up on the simulator. All right, it's a little different. You'll see if we go to some of the offsets on the offset page here, a little different than the mill. You'll see XZ geometry, tip direction. If we go to the other set of offsets for work offset, a little different, only X and Z. We have nothing there. We're using all tool length offset for this example. But if I get into edit, you'll see our program. And then if I get into edit memory graphics, I can run it, and you'll see the program. Okay. I wouldn't really worry about these green lines for now. Keep an eye on it, but don't worry about that. Sometimes it depends on where you are when the program starts and things like that. So I wouldn't worry about it. It looks good. Okay. If we F2 and zoom on this, you'll see what it's actually doing. That discriminator is not. It's roughing the workpiece. So if I hit cycle start, okay, there it is. Okay, so let's change some things here. So notice it's roughing. Okay, where the roughing start point is. So if we get into down here on the program, let's say X, we did X 2.0, where I said sets where roughing begins. Let's get in here and change that to X 3.0, alter. Okay, I'm going to hit memory and go to graphics and run it again, and you'll see how much more it's roughing. So if I go to F2 and zoom out and run it, you'll see that that changes how much it's roughing. So it's pretty easy to change stock sizes, and that's how you control where the material is between the contour and that set initial start point. So I'm going to return that. That's a good example of that. I'm going to return that to normal. So X 2.0, alter, and just memory to save it. And then get back into edit, and let's see what else we have here. Everything looks good. One thing that I did talk about earlier, I think I put a note on it, is the G1 on this line. I know the one cheat sheet says to leave it. That's fine. The issue is when you go to finish, it's going to use that feed rate to work down the face of the workpiece and then start cutting in Z minus. So it could be a little bit of a waste of time. It's not bad for learning because it does slow it down, but you can take this, put it to G00, and then this last line, this Z minus 1.0, you could turn that to a G1. Okay, so that is that's normal. Okay, you can even look at some of the examples. Actually, I'll scan back in there right now in a lathe programming, and just look at a quick example of that, just to give you an example here. Let's see where we're at. It's grooving. Let's look at where we're at here. There they are. And here is our example. So take a look. We're looking at line 11, which is our first line. They are using comp, so ignore G42, but they have a rapid. Then the next line, going to Z0, they have a G1. Okay, so it is a G1 before it gets into anything else, or a cutting feed rate. You don't want G00 on and not change it, because G00 is modal, and that's going to remain on, and you're going to run into issues. Okay? Alright, so here's another example down here on page 83. You'll see the full can cycle. Alright? And there is the G1 going to Z0. Not a bad idea. It goes to Z0. That is still technically not really touching to make sure the G1 is on, and this is really the contour. While this line of code is not only turning a tool nose radius compensation on, which I know we haven't talked about, but it's also rapiding and going to the diameter we want, at least on their example here. Okay? Not a bad way to do it. You could just go in and do Z minus. We could just put G00 in ours, but for now, you know, G01 is fine because it does slow it down and it'll help, you know, avoid crashes at the machine. Okay. Other thing is when it comes to finishing, the finish feed rate is here, not here. So let's look at our program. So if we have our program, we could actually run this. So if I go to edit mem program and reset actually, and I go to run this, I want you to focus on, if I get you guys looking here, I want you to focus right here and right down here. So if I run this program, alright, it's going to face the workpiece, and you'll see our 5 thou feed rate, and right now it's facing, and you'll see the spindle speed turn up. It's going to spool up, but it's going to be limited by G50, and you'll see it's facing, coming down the workpiece, going to 0, and the surface speed is 200, 5 thou feed rate right there. That's 200, and it's going to cap it, and it's going to be under 1,000 because the spindle's limited at 1,000 RPM, but that's what it works out to be. What else we got here? It looks good. Now we're in the G71. Alright, and we are cutting. And we are cutting at 8 thou per rev, which is right here, which is what I want to show you. Okay? So the simulator is not just for graphing, you can actually watch it run. So we're at 8 thou per rev. So instead of watching this whole thing rough, I'm going to hit reset. I'm going to start mid-program at the T202. Okay? And we'll run this, and I want you to take notice. I actually will single block this just in case. I want you to take a look at the feed rate. So we got the G97, all that stuff turns on. M8 is going to that position. And then it's going to have the G70. And it will run. But it's going to run at 3 thou per rev. So I'll turn single block off and watch it run. So see where it pulls that feed rate from? So that's your finished feed rate, not the 8. So that's how that works. Okay. So that's really it. I'm taking a look here if there's anything. I mean, this tells you a little direction here. the chip load. If you don't worry about that for now. This is more when you get to the machine. So this is what you're going to see at the machine. Tool 2, offset 2, coolant is on. If I remember correctly, if I hit reset and get to edit and just go end of program, I have the coolant off. But beyond that, if I just graph it, that's what we want. Hit reset and we're good. And we're good to go. So that should be good. I don't see any real major issues here. That's what we're trying to do, is achieve this, and then we'll take it out of the machine and we'll part it off in another lecture. So that's it for this one. If you have any questions, make sure you email me, and or see me in lab. Thanks.